When the pH is 7, then it's a case where the sample is neither acid nor base. But less than 7, it's an acid, we say. More than 7, it's a base all the way.
Welcome to one of the past HSC exam question videos. We're going to do in this video, we're going to cover this exam question, which comes from one of the past HSC exam questions on the acidic oxides chapter of the acidic environment module. While doing a second, I'll read the question. Once I read the question, give about 5 seconds to pause the video. Once you've paused the video, attempt the question, and when you're ready, press play, and I'll go over the actual answer itself. So the question is, a bottle of soft drink was placed on electrical balance and weighed. The cap was removed and placed next to the bottle on the balance. The mass of the cap, bottle, and its contents was monitored. The results are shown in the graph below. The experiment was conducted at 25 degrees Celsius and 101 kilopascal. Assume that no evaporation has occurred. And this is the actual graph. We've got mass of cap, bottle, and contents on this side. So this is the mass in grams, 615, 620, 625, 630, and time on this axis. The actual question, A, identify the gas released, that's worth 1 mark. B, calculate the volume of the gas released, that's worth 3 marks. So what I'll do first, I'll pause the video. Or actually you have to pause the video, I can't pause the video for you, but you can pause the video and then you can attempt the question, and when ready, press play and I'll go over the actual answer itself. Welcome back. Alright, so for this one, the first question, A, identify the gas released. If you remember this experiment, we have the soda water experiment, and in the soda water experiment, which is soft drink is similar to soda water, the gas that is released is carbon dioxide. So carbon dioxide is removed. So carbon dioxide is the gas released. So all you have to write for that, what I wrote is carbon dioxide. And that gets you 1 mark. It's only worth 1 mark. Now for the second part, we have to look at that graph. What this graph tells us is that initially, this bottle and the cap and everything inside weighs 630 grams. And then by the end, so whatever time, the time amount is not important, but by the end, it plateaued. And this was at roughly this point here. And that would have been about 620. So it started at 630, ended at 620. And then we have to calculate the difference first. The difference in mass. So mass change was 630 grams minus 620 grams, which equals to 10 grams. So we know that there was 10 grams lost, and we've already established those 10 grams were all carbon dioxide. So it also says that no evaporation has occurred, so we know it wasn't water then. So what was lost was carbon dioxide. Now we know that, okay, 10 grams of carbon dioxide was lost. How many moles is that? That's what we need to know as well. We need to know how many moles that was. So we have this equation to get the moles. N equals mass divided by molar mass. So number of moles equals mass divided by the molar mass. We don't know N, that's what we want to get. But we do know small m, which is mass. We know that is 10 grams, which we calculated earlier. We also know the molar mass of carbon dioxide, so CO2. In CO2, that has 1 carbon. The carbon is 12 grams. Each oxygen is 16 grams, so 2 of them, or 2, will be 32 grams. And then add that together, that's 44 grams. So we know 1 carbon dioxide, 1 mole of carbon dioxide weighs 44 grams. We have 10 grams, so that gives us an overall mole of 0, I'll put that in the calculator. 10 divided by 44 equals 0.22, let's call it 0.23 moles. That's the first step. Now we have the moles. Remember, we want to get the volume. That's what it's asking for. It's asking for the volume. And the actual equation for the volume was N equals volume divided by the volume that 1 mole takes up. Now, how do we know how much 1 mole takes up? Well, we have this given. We've got 25 degrees Celsius and 101 kilopascal. And we know, I think, this would be given in your actual back of your test. The list of different equations also has these values, but it should be around about 24.79 moles per liter, and that is for 100 kilopascal. But it's actually asking for 101 kilopascal. That should also be given in your booklet. I think that's what that's about. Again, this is from my head only, from my memory, but it should be about 24.45 moles per liter. So we're just going to use this value here for our VM, but you would have just gotten that from the back of your book. You would have just looked at what you've given here, and then looked at the value from your booklet that you got for your test. Alright, so we have N, we know that, we got that earlier, that's 0.23 moles. 0.23. We have VM, because we were getting that given in our booklet, that is 24.45. And we want to get the volume, that's what it's asking for. Well, we can bring this to the other side by timesing both sides by 24.45. So what that means then, what we do now is we rearrange this one, and then we have given at the end, this will go to the other side for 24.45 times 0.23. That equals our volume. And if we put that into our calculator, our trusty calculator, that's 24.45. That was our molar volume times 0.23 equals 5.62. So our volume is, I'll write that in a different color so you can see, 5.62 liters. Yep, that would have been it. So this, the actual answer for this would have been 5.62 liters. And obviously the most important part is your actual workings, so how you got there. So first we calculated the mass of the carbon dioxide that escaped. Then we turned that into a mole, because we have stuff given, we have the molar weight of carbon dioxide and we have the weight, we can get the moles. And after we get the moles, we put it into our equation, and from there we get our volume. That's why it's worth 3 marks, those 3 steps. And the first one was just 1 mark out of 1 for saying carbon dioxide. And overall, it's worth 4 marks out of 4. And where does this come from? Well, this comes from this dot point. Identify data, plan, and perform a first investigation to decarbonate soft drinks and gather data to measure the mass changes involved. So we measured the mass changes, which was 10 grams. We said that came from carbon dioxide. And then we had to calculate the volume of gas, which was also in part of the question, released at 25 degrees Celsius and 100 kilopascal. The only difference was that it gave us 101 kilopascal. That just means you need to get a slightly different value from your booklet, but you will still have that given as well. But yeah, that should be good. But hopefully that was useful.
Thank you for watching.